they've sort of expanded out, so they're not just specific to the Python language, and I'll talk about that a little bit. So these are sort of just a couple of sort of main points I can talk. They can make slideshows, so just as a showcase, this is made in a Jupyter notebook. You can make presentations in it. So what Jupyter notebooks are a really nice way to interactively work with your code. They're sort of geared towards that kind of thing. And the way that they do this is, what Luke was talking about before, typically when you're sort of coding something, you might have your sort of interpreter in one sort of window, and then maybe a screen that has your script saved in it, you're sort of copying and pasting commands, or if people have used RStudio before, there's usually a shortcut to just send the commands over. Jupyter Notebook sort of turned this up on its head a little bit. Instead of having scripts and execution sort of similar, they fused them together in this concept called code cells. And so these cells, as I'll show you in a second, are ways of actually pairing the output of a command with the command itself, and they just sort of are embedded in this sort of way. They don't only have to be for code either, and I'll give you a couple examples of that, but it's a slightly different way of thinking about things and maybe a little confusing at first. But primarily what it's really great for is getting immediate interactive sort of feedback on what you're doing. So I'll show you in a second. Okay, so this is an example of like a code cell here. So I could put some code in here like setting a variable to 10, and I can execute the code. And now this output here has changed with respect to what I'm doing here. So I can change this variable, I immediately get the output. Now, embedded in here, there's actually 3 code cells. This one is a markdown cell, so I'm not necessarily writing Python code. Now I'm writing markdown, which is just it's a simplified markup language where you can sort of enter command, you can put some sort of notes in here, so I could turn this into a heading. And the really nice thing is you can sort of immediately see that it's different than the sort of scripting, run the execution sort of framework here. Everything's embedded together. I can sort of create plots and put them in line here. So now when I sort of jump between these cells, I have maybe a simple analysis alongside the code that it takes to run it. The thing that's happening behind the scenes is this is all part of the same kernel. Kernel just being the sort of interpreter that's running stuff. So it's the same Python that's running behind the scenes. It's not that each cell here gets its own version of Python. Rather, they're all just breaking them up into these sort of conceptual pieces, but running the same Python underneath. So for example, I could have taken the 10 that I have here, and I could, maybe simulate cursors here, just like multiply this by x and rerun this code. And so that's just to show you that a variable I defined in a different code cell is still shared with the same process because the entire thing is running on the same kernel. So these are sort of this idea of code cells is what makes the core of a Jupyter notebook. So here, I'm running a code cell here. Let me move over here. This can be used not just for Python, but you can do whatever you want to here. So in this case, code cells are basically animating a GIF for me, right? I have a GIF that's pointing to some file on my computer, and this is me actually launching a Jupyter notebook as an example, and all I'm doing is saying, hey, just display this demo. What Jupyter notebooks are made of behind the scenes are just a bunch of HTML, JavaScript, and CSS, so they're all web technologies. And so anything that you could display theoretically in a web page, you could also do on Jupyter Notebook. So that's why a GIF can play. But behind the scenes, they can run any sort of kernel you want to. Okay, so this is just another example of this. They're multilingual, so they started with Python only, but they can use a lot of different languages. So for example, for things that I have to turn to R for when I need to, I can run them in the same notebook. You could actually run and hook up MATLAB to run these things together, so you could have your MATLAB scripts embedded in notebook cells rather than opening up the entire MATLAB desktop application. You could do JavaScript, Julia, a whole bunch of different languages. And the really neat thing about this is you can actually pass variables and stuff between languages. Jupyter sort of offers you ways to do that. So for example, this is me running R inside of a notebook. So this is an R cell. Now I have R code running. I'm using sequence in R. I could do this with MATLAB, and hopefully this will take not too long to run, but this should be theoretically me opening up MATLAB and running MATLAB inside of a Jupyter notebook. So now this is a MATLAB cell. And so you can sort of begin to see that what they really are a sort of language agnostic format for you to be able to do interactive work with code. And so here's another really nice property of Jupyter Jupyter Notebooks. here I'm defining a sequence in R at the top, and I'm setting it to a variable, and then I'm turning it into a Python NumPy array, which is a particular data type that's named to Python. And so this allows you to now sort of move between languages if you really needed to, get some information from one, do processes in another, and vice versa. And you can have all of your stuff in one place. So rather than having to open up one application to work with one language and another one to another, you can keep all of your stuff concisely in a single notebook, which makes sharing and reproducing your work much easier. So GitHub, like I was showing you before, and I'll show you again, automatically renders Jupyter notebooks for you. That just means that you can actually see both the input and the output. So one really neat thing about this is people can actually look at how you've done an analysis along with the results of that analysis without having to actually execute anything. It'll just sort of statically render them. Then based on the stuff I was talking about earlier, if you clone a repository that contains a notebook, you can just launch that notebook and just start running the cells yourself. You don't have access to that stuff. You know, you might need to download some extra Python libraries and stuff if you don't have them, or get R packages if you require them, but it's a really, really convenient format to be able to do that rather than opening up or requiring someone to have a particular text editor or desktop environment framework or something like that. And I'll show you some interesting aspects of this. So Jupyter allows you to sort of customize your notebook experience in different ways, and I'll show you how I've sort of done mine here. But you can profile your code really easily, so you can see how long things take to process. You can clean them up and make them sort of visually look as appealing as you want to. And there's a whole library of these notebook extensions. And if you have any experience writing HTML or CSS or JavaScript and stuff, you can build your own notebook extensions and share them with your community. It's actually not too tricky to do that. You can, for example, embed like an interactive viewer for brain data or something like that within the context of a notebook, which is handy.
Can you just get clarification? So
Yeah.
is the processing actually happening locally on whatever machine you launch? So like you open a terminal window, you launch the Python notebook, is the processing happening on that machine? Okay.
So by default, that's what's happening. The really nice thing about Jupyter Notebooks, this sort of separation they've done between what you're interacting with and what's processing, allows you to do something super cool, which is you can actually have the back end of the notebook, if you're asking, be located on like some powerful cluster. But then you just navigate to your web browser and interact with it as if it was being processed locally.
Okay.
Right, which is, I think, basically impossible with something like a MATLAB desktop, or maybe RStudio kind of has stuff like that now, but, so it doesn't have to be, but by default it will be running your Python, right? A couple other tips and tricks. Again, you guys can, I have a link, I think, somewhere in the Slack about this, but I'll show you some extra features here. The notebook sort of has these magic commands that let you do certain things to cells, including looking at how much memory they're using, opening up debuggers and things like that. And then this is a really nice example of something Luke was talking about earlier, where because you can embed output, code, and markdown information into one location, people have written full-fledged textbooks in Jupyter Notebooks. And the really nice thing about that is you can just scroll through, see the code to do certain commands, but you can also clone them to your own computer and you have a full interactive working textbook. So this is one made by Jake Vanderplas, who wrote the Python Data Science Handbook. And you'll notice that if you go to his code folder, his notebooks folder here, each of these is a chapter and a subchapter of Python commands and things like that that are in the actual print copy of the book. That you can, for example, let's say we opened up this notebook here. This is an example of GitHub rendering the notebook. So you'll notice he's put a lot of information up front here. Here's an example of a code cell and the output it gives you. Here's a plot outline. And so while I can't run these myself right now because they're just being rendered for me, I can easily go back to the repository here and I can clone this on my computer and then open up a Jupyter Notebook server and just run it myself. So that's a really nice example of how you can sort of share these kinds of things with folks. So let me show you sort of how we get started with them. So in the container that we're providing everyone here, you already have Jupyter installed, but if you use Anaconda to install Python, it comes with Jupyter and Jupyter Lab. And how that works is when you open up a terminal, all you have to type in is the command Jupyter Notebook. And when you hit enter on that, it will fire up a Jupyter Notebook for you. And so what that does by default, if I go back to my terminal here, is it's running what's called the Jupyter Notebook server. For all intents and purposes, you don't have to really worry about this in terms of how you're interacting with it. But you'll notice that as long as this terminal process is open, I can just navigate to the location it tells me, which is my web browser here. and I have a notebook server. And so this is showing me some examples of the files that are in the folder that I launched Jupyter from. So I launched it from this Jupyter demo folder. And in here I have the slides that I just showed you, an example notebook, and some GIFs and a README file. And so by default, even if you don't jump into a notebook, this little sort of file browser allows you to preview files if you wanted to. So here's a README file that I've written in Markdown that's just being rendered by the notebook server. But I can just click on any of these to open up the actual notebook. So here's an example maybe of an analysis that you might do. This is how I've set up my Jupyter notebook. I like to have a little table of contents. It's a plugin you can add and sort of hide on the side really easily. This is me sort of annotating how I might do something, and maybe when I publish a paper, I'll break down every single section for folks to be able to reproduce an analysis I'm doing. So here I have some code that's loading in some Python libraries. Now what I'm going to do in the notebook cells, I'm actually going to grab some data from GitHub that I've already put up there. When I create a new notebook cell, so you can just go up here to running cells and creating them, there's a toolbar that Jupyter has by default. I haven't used the keyboard shortcuts, but you can use any of these buttons to create and interact with notebook cells, basically. So this plus icon here should create a new notebook cell for you, and you can sort of make as many of them as you want to. By default, when you're sort of moving around in the notebook, you're bouncing between cells, you can sort of see things happen. And I can just type enter and start entering code into here. So again, by default, this is a Python interpreter. So I have Python code here. I've defined a variable L. I can jump between cells and just say, what was that variable again, and I get the output. This is sort of that notebook paired with the output style that Jupyter brings to you. So the other really neat thing is that if you preface any command with an exclamation point, it'll just send it to the bash, to your shell, whatever your native shell is. In this case, I believe I'm using Z shell, but it'll send it to bash by default. So I'm going to just delete a couple of these cells that up here. And what I'm going to do is I'm going to use bash to run a git clone command that I demonstrated earlier. And I can run that from within the notebook itself, because this is just going to send it this prefixing with a exclamation point, will just send it to the shell. So I'm just going to clone this right now. And so this is going to create a folder that I've cloned on GitHub. And again, you can run bash command from within the notebook. So I could just say, okay, what's in this notebook? And I'll notice there's this new folder that is created for me here. Jupyter itself, and particularly the flavor of Python it uses called interactive Python, IPython, actually has some of these commands built into it. So you don't actually have to set them to bash. You can actually just do this, and you can do the same that way. So what I'm going to do is I'm going to move into this folder, and I'm going to use some Python to point to a particular sample data file. And I'm going to use a library called pandas to load it in. And so here's just the first couple of lines of the CSV file that has those categories I was talking about before. You know, I can run some Python commands, describe, for example. And the neat thing is, like I said, the output is saved here for me. So were I to come back and I wanted to see what I've done before, I already have the results alongside the code. If I were to save this Jupyter notebook, commit it, and send it to GitHub, people would see it exactly like this. So they would see the output alongside the code. They would know what I was doing. I can create plots and figures and embed them within the notebook itself. So here's just a bar graph of that data alongside the code that it takes to execute it. And then I can run full-fledged models if I need to. So I'm just going to run some arbitrary regression analysis here. And the neat thing is you can just print these alongside your notebook here. And so here's like a typical summary table you might expect from something like R for an arbitrary analysis I wrote. And then I could take a notebook cell and say I want to turn it into a markdown cell, and I'm going to say, okay, these are results, and there is no difference between groups. And so this is embedded in my notebook now, and so anytime anyone were to go through my code, I have code alongside output alongside some commentary that I've made on it. This is a sort of general principle of how these kinds of things work in a Jupyter notebook. Maybe I'll pause here for a second. There was a lot of stuff real quick. Are there questions or confusions about this general thing? It's definitely different than scripting or opening up a desktop application and things like that. Do you think I can clarify? Or?
How did you create that example notebook to begin with? Sorry.
Yeah, so I cloned this from a GitHub repository that you guys can access here. So it's located at this URL.
Oh.
Eshin Jolly /GitHub. you can also clone the entire Mind GitHub repository. I think that'll have examples of the other tutorials throughout the week and something there too. Yeah, so that's sort of just a general overview of how to do these kinds of things. One thing I would also sort of point out here is that Jupyter Notebooks are really well designed for doing interactive analyses. But if you're developing code in terms of writing a package or a more complicated thing, you might first prototype things in a notebook and then shift over to maybe a proper text editor for building a software package or some sort of things. I think that notebooks are primarily really good for these interactive use cases, but they make it really easy to write files and things like that too. So I don't remember the exact name, LS Magics I think, but these special characters, if you sort of do double percent times, Jupyter has a couple of interesting sort of magic properties built into it that can help you out with stuff. So for example, if I were to, I think it's this, maybe, I could write stuff here and save it as a file, and whatever's in this cell will now get saved to disk as a particular file if I wanted to sort of write stuff out the disk really easily. I can switch languages if I have the kernels installed for them by just changing this cell type to R, and now this is going to execute R code for me if I wanted to do that. And then what I did before is you can actually turn certain cells into slides if you wanted to sort of create a slideshow and things like that. I believe there's a way to do that that I'm blanking on right now, but plenty of help and stuff like that.
With the code mark.
The other thing you can do is you can easily change the kernel. So right now I'm using Python 3, but for example, let's say I create a new notebook and I want to do some R stuff. So I'm going to open up a notebook that is running R now, and this is R. There you go. This is executed in R. You can't really see it because of my color scheme, but you could run R commands. Just trust me. You can do the same with MATLAB and a bunch of other languages, things like that too. So they're sort of language agnostic in that way. The other thing a relatively new thing that the Jupyter team has introduced is something called Jupyter Lab. So if these notebooks are a little unfamiliar or daunting at first, they've created a more full-fledged, sort of in-the-web interactive development environment. And so what I'm going to do to launch that is just shut down what I was running in my terminal before. And instead of typing Jupyter Notebook, I just type Jupyter Lab. Oh, the other thing to notice is once you stop running the notebook server, this web page is not going to resolve to anything because there's nothing running. So I'll just close these temporarily.
Those changes being saved locally, so like if you're using Git to track the changes in your notebook, if you close it and then usually get status on your command line, it would have tracked all the changes that you made.
Yeah, so if you save them, so Jupyter Notebook files are saved as .ipynb, or IPython notebook files, but that is what contains all the actual changes and stuff.
Okay.
And so those are the files you put under version control. So this is Jupyter Lab. I don't have it, so I'm going to use the Docker container that I gave everyone because that has it in there. I'm going to handy alias for folks here. So all I need to go to is localhost 999 in my web browser. And this is what everyone will be able to do this week to launch up Jupyter Lab. And so this is a slightly different interface, which allows you to not only create notebooks, but also create just like a regular command prompt for Python, or even a terminal, or just open up a text file. You'll also notice on the left it actually has a dedicated file browser, so I could just jump into these folders and see what's in them. It has I believe it has a CSV viewer, so you could scroll through things too. So this is a little bit more like a full-fledged desktop interactive development environment. But I can easily create notebooks too. So let's say I go to the code section and I double click on this notebook. Here's the same thing I was showing before, rendered exactly like it was. It's still a Jupyter notebook file. But let's say that I wanted to open up a terminal alongside of it. I could do that, and this sort of lets you drag and drop things in a neat way to folks that are more familiar with working in these sort of larger development environments and stuff. And so this is just a terminal that's running in the location that I launched it from. I can have multiple notebooks open at the same time. I believe they have like very simple web browser and stuff like that built into them. And so, again, behind the scenes, this is just editing and running the same file. They've just added a couple more bells and whistles if you prefer to have things side by side, or you want some more visual representations of things. This shows me that this notebook is running right now. I can shut it down, or I can end it. I can open up a new notebook if I wanted to. I can customize the layout of different things, and it gives you a couple different options for how to set things up. Yeah, so that's a pretty fast overview of notebooks. And other things that I didn't cover, examples of things, or so personally, like what I like to do a lot, and I know that OSF supports rendering Jupyter notebooks now too. So typically, if I'm publishing a paper, I'll have a preprint up there with data and a notebook to reproduce most of the analyses or generate the figures in the paper, and then folks can just see the code without having to download or install everything and how it works with all the data and stuff like that, which is super, super handy. Yeah, so let's say that you have a notebook you want to share that like lives somewhere on the internet or lives, let's say, in Dropbox. You haven't pushed it to GitHub or something like that. I don't know if I have an example of one, but I'll sort of just pick one here. All you need to do is copy the link to this notebook. Let's say from, this is a little redundant because GitHub already renders it for you, but let's say that this file, I think, let's say it was saved somewhere in Dropbox. So, so this is like Dropbox, is like a bunch of stuff that I have in here. I'm going to take a Jupyter notebook that exists in the Dropbox folder, copy the Dropbox link, and now if I go to nbviewer.jupyter.org, this is a way for you to very easily render to somebody that's not using GitHub or anything like that. Just render a notebook file. You can just point to the URL of it, and this will just load up the file, and you can basically see everything that you would see in the notebook file as if you had opened it up yourself. Again, you can't interact with these. This is just rendering them, but then you can easily just download them using the button up here and run them yourself. This also has a really nice gallery of different kinds of notebooks for different types of things. So here's some Python signal processing stuff. Folks have put tons and tons of examples of different notebooks up there, so you can sort of embed full lectures and stuff like that in there. I know we use them for some of these classes, and it's just a really nice way to be able to easily share and view things with folks. Again, for folks who've already downloaded the container and stuff, I have some instructions on the GitHub README for how to access that. But in case people have specific issues and stuff, I can sort of help you out. But they're all located. If you wanted to open Jupyter Lab, you can just type the JL command or the JP command, and that'll launch a Jupyter book for you with a bunch of Python packages and stuff installed.
Any other questions?
Sorry, I realized there's some error message when I run the Jupyter Lab through the Docker for the line. There's some packages not installed, right? For example, the RPy2
Yeah, right.
stuff, and also the PyMath3. And
Yeah.
also what's the other one?
Yeah, so those are specific factors I was just showing you to do language interrupt.
Oh, okay.
But you can
They
pick
can
something.
install local.
Yep, you can totally install it.
What is the best way to collaborate on a Jupyter notebook which is hosted on a server? Like, is it like, so one way is GitHub?
Yeah.
Uh,
So, yeah, that's a good question. So, personally, I think that one thing that's super exciting is Google has launched this thing called Google Collaboratory. So anyone here that has like a Gmail, I think, can just you can just ask them for a link and they'll just auto preview. This is pretty wild. This is basically the marriage of Google Docs and Jupyter Notebooks. So if I give this link to somebody else, they can actually add and execute code, and I'll see it run. So
Just drop it in Slack and Someone else can jump on.
Yeah, let's see if that works. I think you have to have a collaborative already, like everyone should have one. So this one comes installed with TensorFlow, I guess. So they give you some cool stuff that things are already installed, but let me go to this one quick. Yeah, they give you some GPU resources, they give you a couple of neat things. You have to pay for more. So I think, let's see. So I can.
But then you have to upload your like the MD files to it.
Yeah. So the one thing that's the downside of this is that if you want to get custom packages and stuff, you can install them. You could run, for example, pip install, Seaboard, which is a visualization package, and this will. Google has provisioned like a computer for you in the cloud, essentially, a container that you can install and modify. There's some caveats to what you're allowed to do, but they're reasonably lax in a lot of stuff. I don't remember how to share this. So you'll notice that that's my account, my Google account thing next to it. And what they do is they use Google, so all the notebook files themselves are stored in your Google Drive, so you can actually share the files there if you wanted to, or download them to your computer and so on and so forth. Good one, everyone, getting done.
You have to change the sharing to anyone else can share. Great.
Oh, yeah, there it is. So now you should be able to, there we go, there's an anonymous animal in here that's doing stuff. There you go. Right, so this is actually really cool, I think. It's sort of in an alpha phase for a while, and I believe Jake Vanderplas is doing a visiting residency at Google right now, and it's going to like really help them build this out for your typical data science use cases and stuff. So this is something to watch out for becoming, I think. Oh yeah, this is cool too. So they've embedded this sort of search Stack Overflow functionality where it'll automatically take your error messages and then send them over to Stack Overflow for getting answers and stuff like that. There's a lot of people in this stuff.
Jupyter, what?
I don't know about Jupyter Hub. Jupyter Hub is another way to do this. So this is if you want to custom provision a thing like Jupyter, Google Collaboratory. If you have like a, let's say a server you're running in your lab and you want multiple people to sort of collaborate in, Jupyter Hub is a way to be able to do that. I guess Binder is the other way to do this. So
The binder's running Jupyter Hub in the pack.
yeah. So this is a really nice other sort of application here. So you can, there's two sort of things people can do with Binder. You can actually point it to any GitHub repository that has Jupyter notebooks in it, and it will create a custom temporary compute instance that anyone can access for I think an hour or two and just run the code. So if you want people to actually be able to reproduce something physically on their computer without having to download anything, you just upload your notebook files to GitHub like you usually would, and then you can create a Binder instance and point to it. It'll just spool up what it needs to for a short amount of time. That's also a pretty amazing application. So you could add this stuff. You could get like a hard-coded URL to it and stuff like that.
So they wouldn't need to like download your data to do this.
It just grabs whatever's in the GitHub repository.
Oh, okay.
Yeah.
But it does, it's pretty cool. It'll try to figure out what packages, Python, what packages it needs. It spools up the Docker container in the back and builds a mini conda thing, trying to figure out what libraries it needs on the back.
Yeah, so for example, like the demo thing that I was showing you that doesn't have some of the packages installed, you could theoretically, it takes a couple minutes while we wait to do this, but you could copy that URL, put it in there, it'll figure out there's some packages that I'm using that are not installed, and it'll install them.
And it caches it temporarily, so if you have like a class, in theory this is cool, it's still really early in development, but you can have everybody log on and they all have access to the same thing, So if you had like data or like a notebook, then they all log on, but they're all logged into the same Docker container in the backside. So,
What if you're working with, so like I'm thinking, what if you're working with human imaging data that's not yet identified, like you're trying to send your collaborators, what sort of workarounds do you tend to use for that? Or you just say like point it to the lab server?
yeah, so that's a different one, but that's more about the data sharing side. Yeah, it's a good question. That's a little trickier about that, right? This is just saying the code, we obviously need the data to run
Yeah.
the code. So one thing you could do, depending on how it is, so there's neurobots, which I don't think we're gonna talk about too much, but it's a web sharing data repository, and it's more for like higher level stuff. So after you've already kind of pre-processed the data, it doesn't really handle huge data sets really well. Like you can't really pre-process it, although there's another one for that, OpenMRI or OpenMRI. But you can actually have private collections on here, and then we've made a Python toolbox so you can download it directly into your like notebook or whatever from this. This is an API, so you can call the collection and download it. So I've used that in the past if I want to share some images with other people. I have the links on how to, and then the code to how to download